Hey everyone, Mr. Skellin here. We are back at it for lesson 2 in unit 10, and today we're going to be talking about inverse variation. Yesterday, or in lesson 1 I should say, we talked about direct variation. Let's just review that real quick. Direct variation always comes in the form of y equals k times x, where k is the constant of variation. And when two variables, x and y, vary directly, that means as x increases, y also increases. Okay, that's what we kind of talked about yesterday or on lesson 1 when we talked about it in terms of a graph, x-axis, y-axis. Remember, we talked about that this was a linear situation. If you think of example like y equals 3x, it's kind of like slope-intercept form, right? As x increases, like 1 to 2 to 3, it's going to get multiplied by 3, so your y values will increase. So that's direct variation. Today we're going to kind of do the opposite. We're going to talk about inverse variation, just another form of variation, basically a relationship within two variables. So let's just jump right into it. So we have a situation here where we're renting a bus to go to Cedar Point. Always a great place to visit. $120 for the day seems a little low, but hey, it's the example. Let's just deal with it. You do not know how many people will be going with you, but you want to split the cost among. You want to split the cost equally. Should be equally. You want to split the cost equally among all the people. Let x be the number of people that are going to end up going, and y be the cost. So let's just take a look at the situation that we have going on here. If one person rides this bus, they're going to have to pay that $120 by themselves. Obviously, we want more people going on the bus, so the cost per person decreases, right? That, what I just said, is kind of what inverse variation is. As your x values go up, as the more people increase, your cost is going to come down. So if you caught that, that's what inverse variation is. But let's just keep going. If two people ride the bus, then that $120 gets split into 60. If 4 people ride the bus, then it's going to be $30 per person. And then this should be $12 per person, and then 6, and then 3, right? And so what's happening here? What is going on? Basically, we're taking that $120 and we're dividing it by the number of people, and that's going to give us the total cost per person on the bus, right? So that's an example of inverse variation. The equation that we would use here is 120 over x, okay? If we were to graph this, this is a little bit different than what we graphed before. So if you graph these points like 1 and 120, and I'm just going to estimate here, 2 and 60, 4 and 30, right, 10 and 12, and then 6 and then 3, we would get something like this. Oops. But what I also want you to understand is if I put a negative in front of all of these numbers, which I could, right? When you make a T-chart, it can be positive or negative numbers that you pick. What's going to happen to all your resulting y values, right? 120 divided by -1 would be -120, so all these would become negative. So what we would get is something like this: -1, -120, -2, -60. Again, I'm just estimating, but we'd get something that looks like this. You haven't learned what this is yet. This is called a hyperbola. And we're going to learn about that later in this lesson. That's called the hyperbola. All right? And you're going to see this because I'm going to graph some of these, but we're actually going to spend a lot of time on graphing. I know I'm getting ahead of myself a little bit, but we're going to spend a lot of time on graphing in lessons 4 and 5, but I'm kind of giving you a head start today. There's a little pattern that I want you to figure out, that I'm going to have you figure out today as we go. But basically, if you take the square root of your k value, that's going to give you your middle point on inverse variations here and here. So you take like 120, you take the square root of 120, just doing it on my calculator real quick, you get basically 10.9. When you graph the hyperbola, 10.9, that's going to be somewhere in 10.9, 10. It's basically what I'm doing is, if you take the square root of 120, you're going to get 10.9 for x and 10.9 for y, right? Because 10.9 times 10.9, I got on my calculator, the square root of, oops, hello, there it is. The 10.99, if you look at the equation for for inverse variation, if you were to cross multiply this or solve this for y, you would take your x value times your y value. And so that's why this 10.9 and 10.9 would be your starting points, because we're going to end up shifting those later. Okay? At any rate, let's get into the second page and talk about what we have going on here. So that first example we did was kind of to show you a real life example, or real world example of what inverse variation is. So what is inverse variation? Essentially, it's this. When one variable goes up, the other goes down. So you could see in that example we just did, as our x values increased, right? The amount of people on the bus were increasing. What was happening to our y values? The cost was going down. So as our people increased on the bus, the cost came down. That's inverse variation. Here's the formula that we would use right here for inverse variation. You're going to want to know this. It's y equals k over x. Remember that direct variation is y equals k times x. So you got to know both of those. Those are important for the first two lessons. Okay? K is still the constant, or the scalar. That's the number that is going to remain the same. So the example we just got done doing, the cost of the bus is basically 120 over x. Okay? We'll get into graphing as we go. So let's just keep looking at some problems that you're going to have to do on your assignments and see if we can figure them out. So basically, here's a table of values. You got to come up with the equation. So what does that mean? Well, what's the equation we're using? We're going y equals k over x, because we're talking inverse variation. So if we want to find our k value, how do we do that? Well, you'll get better at it as you go, but basically just plug in the values. 12 equals k over x. x3, y12, solve for k, right? Times by 3 on both sides, and you get 36. So look at this. You get 36. 6 times 6, 36. 18 times 2, 36. So my k value is 36. How do you find your k value with inverse variation? You times x and y together to give you your k. So the equation would be y equals 36 over x. Again, if you were to graph this, you could make a t-chart, which you see here, right? So 3 and 12, 6 and 6, 18 and 2, and you're still going to get this hyperbola here. If you put negatives in front of your x's, you would get the same thing going here. Again, when you start to see the pattern, if you take the square root of 36, which is 6, you'll see that 6 comma 6 is there. Negative 6 comma negative 6 is there. And that's really the only point you need. You just need one point if you understand that it is a hyperbola, which you will as we do more and more. Okay? Take a look at this one here. So we have 2 times 48, 4 times 24. We got basically what, 96 is our k value. So we'd have y equals 96 over x. Again, if you were to graph this, if you wanted to do it real short and sweet, you would just take the square root of 96, hit equals, and that's 9.97, so roughly 10. So I would basically go 9.79, 9.79, put a point there, and there's your hyperbola there, and then negative 9.7, negative 9.7, and there's your hyperbola there. We're just doing some rough sketches, okay? Now, we've got a couple different situations here. Now our k value is a negative number, okay? So let's take a look at this. I believe I wanted you to graph these. Helps if I put the directions on there, right? So what do you want to do here? Well, let's take a look. Let's make a t-chart, because that's always helpful, right? And let's pick some values for x that make nice, neat values for y. So let's pick a positive 1. Okay, pick a positive 1 for x, we get negative 9. We already know our k value is negative 9. We already know that. Let's pick a 3. If I pick a 3, I'm going to get negative 9 divided by 3, which would be negative 3. And I'll pick positive 9 and get negative 1. So let's graph that. 1, negative 9. So 1, negative 9 would be somewhere down here, right? 3, negative 3. So 3, negative 3 would be somewhere in here, roughly, okay? And then 9, all the way over here in negative 1. So what do you notice about our graph? Well, look at these two graphs here. You'll notice that the hyperbolas are taking place in the first and third quadrant. first and third quadrant when our k values were positive, right? Now that our k value is negative, what do you see happening here? We're going to get this action, which means it's going to be in our second and fourth. So if your k value is negative, you're going to get those hyperbolas to show up in the second and fourth, okay? Because if I put a negative, just like I did before, if I slapped a negative in front of this 1, what happens to the 9 now? It becomes positive. So -1, +9. There's that point. But again, if you just take your k value and take the square root of it, now you're thinking, well, it's -9. I can't take the square root of a negative number. Yeah, you gotta think a little bit. Just take the square root of 9, understanding that it's negative. You're going to get 3 and 3, 3 and 3. But knowing that it's going to be in the second and fourth because your k value is negative. All right. This one here is challenging. The first problem that always gets people is, what's your k value? Well, your k value is actually just going to be 2/3. This can be rewritten as y equals 2/3 divided by x. Okay? And so now, if you had to graph this, a lot of people would go, whoa, that's kind of challenging. If you make a t-chart, all right, you're thinking, okay, I put a 1 in, I get 2/3. Like, what numbers am I going to put in here to make it easy? Well, if you use the shortcut and just take the square root of 2/3, so second square root of 2 divided by 3, you basically get 0.8, right? So your k value is positive. It's a positive, so that means it's going to be in your first and third, and I get 0.8, which is basically 1 and 1, right? Just a little bit less. So somewhere in there, hyperbola would look like this, and -0.8 and -0.8. Now, one thing that I want to point out about all these graphs, and I kind of didn't explain this yet, I'm waiting till the end. You'll notice that none of them cross the x-axis or the y-axis. So in highlighter here, what am I putting dotted lines in for? What are those called? Those are called asymptotes, right? These graphs never touch the x-axis or the y-axis. They get really, 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 really close, right? But it's never going to touch that. Same thing I could say on the two original that I did here. These never cross the x and y axis. There are horizontal and vertical asymptotes on each of these. Think about that for a second. If you go back to our original problem with the bus, you're never going to get $0. Like if you had 50 million people on a bus, which is impossible, they're still going to pay something. It's never going to get to 0. So that's why those asymptotes need to be included on your graphs. And we're going to do more of that in lesson 4 and 5. Okay. So we already kind of talked about the graphing, so I'm actually going to skip this one because you should be able to graph this on your own because we've done so many of them. And then let's get to the problems on the back where these are very similar to the problems we did in direct variation. So it says writing an inverse variation equation, so you should be thinking this right away. Okay, y equals k over x. Get that on the picture there for you. It goes through the point of 5 and 8. Write the equation. Okay, so y equals k over x. We're plugging in an 8 for y and a 5 for x. We're solving for k, so I times by 5, so I get my k value to be 40. So now I have y equals 40 over x. That's my equation. That's answer 1. Okay. Then it says find y when x is 20. So you would just plug in 20 right here, and y would be 2. That's your second answer. Same thing here. Here's your x. Here's your y. Y equals k over x. So you plug in the 20 for the y, 10, and you get 200 for k. So that's your k value. So the equation that you need is 200 over x. That's answer number 1. Write the inverse variation equation, and then answer number 2, and then find y when x is 4. So 200 divided by 4 should be 50. Okie dokie. Artichoke. Inverse variation, got to be able to graph it. You have to be able to write the equation given a point. And understand that when you graph it, you know what quadrant you're in based on the k value. If the k value is positive, that means your graph is going to take place here and here. If your k value is a negative, you know you're going to be in quadrant 2 and quadrant 4. As always, look forward to answering your questions in class. Take care.